Okay, now that we have our runtime with the two palettes configured here, we will start to simulate a transaction, simulate all the steps that every transaction, every block will have in our blockchain. So let's follow all the steps that we have here to create the first code using our existing blockchain. So the first thing is that I want to create a variable, a mutable variable, because it's the runtime will have state, and the state will change, like balances and things like that. So it is mutable. And then I create a new empty runtime, doesn't have anything. So this is the first thing I need to do. And then I'm gonna set the balance, Alice's balance, to 200. This is the genesis state. Every blockchain starts with an initial state before any transaction, before any block. So let's create a variable for Alice. So this will help us in future. Let's create something for Bob also, because we're gonna use Bob also. And then let's have Charlie as well. Okay. So I'm gonna set Alice's balance to 100. Okay, runtime. Where is the balances? The set balance function inside the balances palette, and that's why I do like runtime balances set balance 100. So now Alice has 100. Okay, done. And let's start emulating our blockchain. Increment the block number in the system. So runtime.system.increment block number. So now the block number is incremented by 1. I should assert that this block is actually what I expected. I expect it to be 1. Now the block number was initial block number. If you go to the system, you're gonna see that the initial block number is 0. So when I do an increment here, the new block number is 1. Okay. And then I should assert if the block number is what I expect. So yeah, I did it. I just did it. Okay, let's create our first transaction. Before creating the transaction, I need to increment Alice's nonce. How do I do this? Runtime.system increment nonce Alice. Perfect. Incremented. Now I want to transfer from Alice to Bob. Transfer runtime balances transfer from Alice. I need to clone it because I need the real value, so I need to clone to pass to the function. I'm gonna clone Bob as well, and I need to transfer 30. Okay, so this would be a way to transfer. It works, but I need to track the error, and because if I just do this let underline equals, because I won't use this result for anything, it will work, but if it fails, I will not know what happened. So to know what happens, I need to create this map error. And so let me explain a little bit better so you have the full picture of it. Imagine that I have this result. Remember, the result is a type that has okay, if it's okay, or an error with a description of the error if there is an error. Okay, so in this case, if I can do like res match res, and this would be the two possibilities. The result is okay, which is doesn't matter what is inside because it's an empty type. So there's nothing inside, unit type, or is an error. So instead of doing all this code here, like if the result is okay, print something. If it is an error, print the error. I just do this map error, which is map error, which is simpler than, oh, wait a minute, I need to remove this. So basically, just recap. I transfer, and if it is an error, it will print the error here. And I don't need this variable for anything, so let's put an underline here. And this is how I just transferred 30 from Alice to Bob. Okay, let's remove this. And then I should transfer and capture the result in an unused variable. And let's do it again. Increment the nonce again and transfer 20 to Charlie. So let's do exactly the same code, same everything, but instead of Bob, it is Charlie, and instead of 20 is 30. And mapping the error, and this is everything I needed to do to create Charlie. Oops. And if I run this code here, I have all this working. And in the next lessons, we will learn how to print the actual state of the blockchain, so we can check if everything is okay, if everything is correctly done.